The wall crane supports a load of 700 pounds. Determine the horizontal and vertical components of reaction at the pins A and D. Also, what is the force in the cable at the winch W? Repeat again. We'll determine the horizontal and vertical reactions at pins A and D and the cable force at the winch W. First, let's build a clean free body diagram of the structure. We have a horizontal beam from A to C, 8 feet long. At midspan B, a diagonal member goes up to D on the wall. The vertical distance from A to D is 4 feet, and the horizontal distance from A to B is 4 feet, so member BD is at 45 degrees. The load at the end is 700 pounds supported by a small pulley labeled E. Because the cable wraps the movable pulley, there are 2 upward cable segments sharing the load. That means 2T equals 700. So the tension everywhere in the cable is T equals 350 pounds. Now place the key forces on the beam for equilibrium. At point B, the cable pulls along a direction 60 degrees above the beam with magnitude T equals 350 pounds. At point C, the load produces a downward 700-pound force. Member BD is a 2-force member, so it pulls along its axis at 45 degrees. Take moments about pin A to eliminate the unknown reactions at A positive counterclockwise. Sigma of moment at A equal to 0. TBD times sine 45 degrees times 4 feet minus 350 times sine 60 degrees times 4 feet minus 700 times 8 feet equal to 0, and solving gives TBD, approximately 2,409 pounds. Now apply force equilibrium to the beam ABC. In the horizontal direction, AX minus TBD cosine 45 degrees minus 350 cosine 60 degrees equals 0. Thus AX equals TBD cosine 45 degrees plus 350 cosine 60 degrees, which is about 1,878 pounds to the right. In the vertical direction, sigma of force along y-axis is equal to 0. AY plus TBD sine 45 degrees minus 350 sine 60 degrees minus 700 equal to 0. Thus AY is about 700 pounds upward. At point D, we already know the TBD value as resultant force, so dx and dy can be solved easily. dx equal to 2409 cosine 45 degree equal to 1,703.1 pounds, and dy equal to 2409 sine 45 degree equal to 1,703.1 pounds. Finally, what is the cable force at the winch W? Because the rope tension is uniform, the winch tension equals T, which we found to be 350 pounds. To summarize, the cable tension is 350 pounds. Member BD carries about 2,409 pounds. At pin A, the reactions are about 1,878 pounds to the right and 700 pounds upward. At pin D, the reactions are about 1,703 pounds in both horizontal and vertical directions. Here is the way that we compute the horizontal and vertical reactions at pins A and D and the cable force at the winch W. Do you think this videos help you or not? If it is helpful, share this video to your classmates. Don't waste your time, study because you still have a chance. Thanks.